Hi, my name is Joe. I'm a developer at a company in Kansas City called Dimensional Innovations. We're a build, design, and execution firm that builds like large-scale physical manifestations of experiences. I've been programming for, I don't know, maybe more than 10 years professionally, and I started as a kid using Flash and ActionScript 1. I've grown up making a lot of different things. I'm an amateur home remodeler, and then I am a father of three young daughters, Jane, Ruby, and Lucy. They're 2, 3, and 5 years old. So I know there's a lot of international people on this call, so I wanted to talk just for a second about Kansas City. This is Kansas City, Missouri. This is my hometown, and this is where it's at. So we're right in the dead center of the United States between Kansas and Missouri. So I am going to talk about laser cutters and JavaScript a little bit, but I just wanted to talk about data in a general sense. This is a concept I've been thinking about for a little bit. It's something I'm just kind of loosely calling data forms. And in this talk, I want to talk about how I've been thinking about data, how I've been presenting it, and then the techniques I'm using to bring that data into the real world. Sorry, I forgot to start my timer. I'm going to start my timer. So as developers, when we get data, it can come in a variety of formats. This is a very common format where we have 2 columns. We have a date and a value. So we break this up into pieces. So if we want to display, the value for a given date range, we grab that and we graph it somehow. And this is a really normal way that we do that. And this works fine. We use a variety of different frameworks and techniques to display this. And like this is kind of a tried and true method where the x-axis is the date and the y-axis is the value. So in this particular example, we're looking at financial metrics for a company. This is some like revenue. So you can see on October 1st, there's some amount of revenue, and then it increases as we go forward in time. But you can get like different like kind of neat effects if you start asking strange questions about your data. So normally, time is X and value is Y. But what if time could be X and Y, and your values could be X and Y? Like, what does the data start to look like if you do something like that? So in this example, we draw a circle. So we want to draw our data around a circle. So we put something in the center, and then the farther away that data point is from the center, the more value that particular point of data has. So if you look in the top right, that's what we started with. And now in the middle, that's how we draw X and Y at the same time. And we just go around the circle, and the farther we are around from the center of the circle, the more value we have. So it's same graph, different way to display it. So we can continue asking strange questions about this. So when we're working on a screen, we kind of have this concept of Z, or like depth, but it's a little harder to express than it is in the real world. But what would that look like if time is X and Y and Z? So we have our graph, and then we can start like layering this. So we can kind of look through the data and like pretend that's like our Z. So in this case, like we can imagine looking straight through it, and the smallest one in the middle might be like a financial quarter 1. The second to biggest one is financial quarter 2, and the biggest one is financial quarter 3. So now instead of having a single line graph, we have 3 circular line graphs. Cool, that's fine and all, but like what if you could touch it? Like what does it look like to get data like out of the screen and feel it. So this is one of the first physical data pieces that I made. This is a laser cut piece, and then each square represents one financial quarter, and they're stacked chronologically. So the very top one is going to be the highest value one, and that's 2018 quarter 4. And then if you look at the image on the right, you can see at the bottom, we see 2014 quarter 1. So this is 4 years of financial data grouped by financial quarter stacked vertically. And these are made of laser cut acrylic pieces. And then the graphs are etched into these acrylic pieces. So if you look down it vertically, you get this kind of neat effect. These pieces are stacked on a piece of brass pipe and then mounted on a piece of quarter sawn oak. So how do we like go about making this kind of thing? I had not worked with a laser cutter before I kind of went down this path, and it wasn't too hard. Laser cutters take SVG documents and obey a certain set of rules. Each one is like a little bit different, but it's common that if you draw a line with 1 pixel width, it calls that a cut, and anything greater than 1 pixel or 1 point is going to be an etch. So in this case, the pink lines, those are going to be my cut marks, and the black are the etch. And drawing these, I use D3 to draw these shapes, but you could really use any kind of graphing framework that can output an SVG. There's a lot of laser cutters on the market. I was lucky enough to have access to an Epilog Zing. These, I taught at an art school for a semester, and they allowed me to use their tools. But there's occasionally these are available at local libraries or local maker spaces. One of our libraries in Kansas City actually allows you to use this. But they are a little bit on the pricier side, so they're hard to obtain for home use. If you're looking to kind of try laser cutting for the first time, Ponoko is a great company. You can create SVG documents, specify materials and material size, send it to Ponoko, and then occasionally they'll ship same day, depending on where you are in the world. Cool, so that last one was one way to look at data. We had that line graph and we thought about it a little differently, but we display data in different ways too. So take this data set. This might be like survey results. I guess we were polling just a second ago, so we can imagine this is polling data. So let's say there's a question with 4 possible values, A, B, C, and D. In this bar graph, the more A you have, the taller that bar graph item. But for my particular case, I wanted to make a data visualization for American baseball. And you don't need to know the details of how American baseball works, but there's a player, and he sits at home base, and he has a bat, kind of like a cricket bat. And somebody pitches in the ball, and he'll try to hit it, and he'll either go to the first base, the second base, third base, or he'll make a full circle, and that's called a home run. So in that previous slide, you can see on the bottom right that first bar graph is how many times he made it to first base. So we call those singles. The second bar graph is doubles, so to make it to the second base. The third one is triples, how many times they made to third base, and then the fourth one is going to be how many home runs or how many full circles that player did. And then I wanted to ask like a different kind of question about this data. So what if what if like the data looks like what it represents? In that previous example where I stacked the laser cut pieces of acrylic, you know, it doesn't look like finance. It's a graph and it's a cool way to do it, but it doesn't, you know, look like the thing. Like, so how do we make data like literally look like baseball? So this is a baseball, and I think that in like elementary school, there's probably graphs like this you see, and this is a very naive approach. It's like, oh, we'll show, you know, more baseballs for more data, and that's kind of okay. But I think we could think about it maybe a little bit more interestingly. So here's our baseball field. This is the professional team in Kansas City where I'm from. And baseball fields have this, it's called a baseball diamond. And it's this real kind of like unique thing to this particular sport. So that's kind of a cool spot to start. So how could we make like data use baseball diamonds? Like what does that start to look like? So there it is. There's our diamond. And we're going to take the same approach that we took the line graph, and we're going to draw a dot right in the middle. And then we're going to start dragging each corner of the diamond out to emphasize like how many hits of a type that a given player had. So here's one particular player, and you can see that they have a large number of home runs. So that last bar graph item draws the point of the base of the diamond away from the circle. So that's how we're going to emphasize quantity. So that's cool. We got a shape, but it's kind of like not baseball-y yet. So like there's no rules against like decorating your data. Like we can decorate it. Like why can't we like put something on top of it to make it feel even more like part of what it is? So even though we got the shape in the middle, we can throw like a baseball diamond on top of it to make it feel more baseball-y. And then we can label it too. So this player is Babe Ruth. He's a very famous American baseball player that played long ago. And it's common for young kids to collect what are called baseball cards. And these cards usually have a picture of a player, and then on the back, they contain statistics about that player. This is Pookie Bernstein. He's from Bryan, Texas. That's my hometown. And then this is the laser cut result. So these are wooden baseball cards. And here we have Willie Mays and Hank Aaron and Stan Musial, Sammy Sosa, lots of famous players, but they all get stacked together and put in like a little box. These are made out of I think it's 1/8-inch birch. So this is just a piece of wood that I picked up at the hardware store. I created my SVG document, and then I put it into the laser cutter. My SVG document that I made obeyed the rules of the cut versus etch lines, and then I had these baseball cards. I'm not like the best pro laser cutter, like I'm still learning a little bit. So you can see like on my box, I had these burn marks. That happens because when you work with your laser cutter, you need to be careful about like the intensity of the laser, depending on the material that you're using. If you ship to somebody like Pinocchio, that's something that they'll figure out for you. It's Mickey Mantle and George Brett, two other famous American baseball players. Cool. So back to data. I am going to talk just a tiny bit more about baseball, because I like baseball stats, and it's kind of fun. So we talked about like how a player hits, but that, you know, there's lots of other stats. The Kansas City team is famous for what are called steals. So this is a different statistical measurement. And it can be represented like this, or like in a variety of different ways. but this would be like Kansas City steals over time. And you could think of this maybe from like 1960 to present day. And this is how many steals that they have per game or per week, just graphed over time. But we could start chunking this data and like collecting it differently. So I can chunk this data and think about it like in year terms. So I can say, hey, that's 1 year, 2 year, 3 year, 4 year, 5 year, and start building these years out to get like data grouped. And then once I group that data, before, like I had like a variety of data points to build circular data. On this, I have one data point, so it's quantity. And I'm gonna draw a circle per year, and the larger the diameter of the circle, the more quantity for that given year. So you can think of each circle as a year. So maybe the one on the left is 78, then the 79, 80, 81. Then we can use our same rules to generate an SVG document with cut and etch patterns, send that to a laser cutter or operate a laser cutter, and then we can stack that data and we get like a radically different visual effect. Acrylic's a common material to use in a laser cutter. I chose blue acrylic, and then I spray painted some wood parts that I found at a local craft store gold to match the Kansas City Royals theme. All right, so back to data again. Like we have this data series, but even in those physical examples I gave, we're looking at data like all together. We're looking at it all together. We're looking at the whole set, and our graphs do the same thing. But like we don't like have to do that. Like what if you could only get like a piece of data, like, and you had to experience that data now. So in these graphs, it's a graph and it lives there kind of forever, and you can see it wherever. But what if data like kind of vanished after you experienced it? Like what if you could only see it while it existed? And what if it was like a little more visceral? Like what if it gave you like a more of a feeling? So I made this. Oh, and I think I might have forgot to share my sound, but that's okay. I can speak to this. So what this is this is a machine that uses a few laser cut parts, some metal from a hardware store. This piece in the middle, this big, large circular disc, is called an electromagnet. And that allows us to fire a signal to move that magnet. And then what's the data we're seeing here? This is going to be real-time financial metrics for a company. So when something happens, and like if there's more activity, more financial activity for what this measures, it beeps harder and faster. So the more data input we have, the more we're going to see that bounce. And then if it's quiet, we're going to see a little less of a bounce. So we'll have a little less movement. But you can think of it that it was inspired by just a heartbeat. The red things are just LEDs, and then there's a microcontroller in there that reads from a node server. And I think I got 1 or 2 minutes left before Q&A, so I'll talk a little bit about the architecture of that little thing. So I've made a few of like those kind of more like mechanical pieces of data, and I've used the same pattern a few times. But over on the left, we have some kind of web of application data or something that's writing to some kind of database. And it writes to that at some unknown amount of time. It's going to be completely dependent on you know, where that data is and where it's coming from. Then I use some kind of node server to regularly pull for that data. Maybe a cron job that runs, you know, every minute or maybe every 10 seconds, depending on the use case. This writes to another web server called Particle. Particle's both a chip and a web service. So you can message to Particle and they will handle the messaging back to your actual physical device. So I pull the database, I message to Particle all the time. My microchip gets that message and then does the correct kind of heartbeat frequency depending on the message. Cool. I think I got maybe 10 seconds left or so, but I do have a website to kind of create your own laser cut sculptures. It's dataforums.joelongstreet.com. It's kind of a work in progress. It kind of works, but it's something to check out. It's kind of fun. And any feedback you have, I have a GitHub page associated with that. So I'd love to hear it.